Hi guys, today we're going to solve a kinematics exercise involving displacement, velocity, and acceleration. First, let's recall how these three functions of time are linked together. Velocity is the derivative of displacement, and acceleration is the derivative of velocity. Therefore, if we differentiate the displacement once, we find the velocity, and if we differentiate it twice, we obtain the acceleration. Now, since the process of integration is the inverse of differentiation, we can rewrite all this in terms of integrals. Velocity is the integral of acceleration, and displacement is the integral of velocity. Hence, if we integrate acceleration once, we find velocity, and if we integrate it twice, we find the displacement. Now, we're ready to solve a kinematics exercise involving these three concepts. Here's our problem. We have a particle moving in a straight line. The velocity of this moving object is measured in meters per second, and it is given by this expression in terms of time t measured in seconds. First question is, after 10 seconds, what is the instantaneous acceleration of the particle? Meaning, the acceleration at that precise moment, rather than the average of the acceleration over the first 10 seconds. Second question is, assume that the particle doesn't start at the origin. Instead, it begins a journey with a displacement of 11 meters already. Then, find its displacement at time equals 2. Let's answer these questions. In question A, we're asked for the instantaneous acceleration after 10 seconds. Acceleration is a derivative of velocity, and differentiating v of t, we obtain this expression. Evaluating this expression at time equals 10, we obtain 1206. But 1206 what? Let's see. Acceleration is the rate of change of velocity. In this exercise, velocity is measured in meters per second and time is measured in seconds. So acceleration is going to be measured in meters per second squared. Hence, after 10 seconds, the instantaneous acceleration of the moving particle is 1206 meters per second squared. Done with A, let's check out question B. In question B, we are asked for the displacement after 2 seconds. To compute the displacement, we integrate the velocity. Now, we still haven't figured out precisely the function s of t, since the constant of integration is still unknown. However, we're given some extra information. They give us an initial condition, which is what happens at time equals 0. Let's use this information. Evaluating our expression at time equals 0, we obtain the constant of integration. On the other hand, we're told that the particle starts with a displacement of 11 meters. If both c and 11 equal this expression, both amounts must be the same. Now we can substitute the value of the constant of integration into s of t. Finally, we evaluate s at time 2, obtaining 43. A 43 what? Let's see. Displacement is the integral of velocity. And in this exercise, velocity is given in meters per second, and time is given in seconds. So displacement, the function s of t, must be given in meters. This means that if the initial condition of 11 meters of displacement had been given to us as 1100 centimeters, we should have converted it to meters before doing any computations. Summing up, after 2 seconds, the moving particle is 43 meters away from the origin. Hence, we're done with question B. I hope you enjoyed this video on applying calculus to a kinematics problem. If you have any questions, please leave them in the comment section below. See you next time!